Today we're going to talk about special number sets. So we have 4 types of numbers that we are going to focus on. So the first type of number are going to be our real numbers. The symbol for real numbers is a R, and I call it a double-sided R. And that is basically the set of all numbers that can be plotted on a number line. So you can plot 2, you can plot 2.5, you can plot fractions on a number line, so any number. So remember, in prior courses, either in Algebra 2, Geometry, or Math 2, or Math 3, you were told about numbers that were imaginary, denoted by the letter I, the lowercase letter I. Any number is a real number if it doesn't have an I on it. That's the easiest way to think about it. So examples of real numbers are -14, a +3, 3.72. You can say pi is a real number. The square root of 5 is a real number. All of those are examples of real numbers because they do not have an I on it. And we can even do fractions as well. So I can say 9/4. All of those are real numbers. The next type of number that we have is talking about the set of all numbers that can be written as a fraction. So we call these numbers rational numbers because think about the word ratio. You can write a fraction. You denote that by a Q with a vertical line going through it. And any number that can be written as a fraction. So we already know 1/2 is a rational number. 3 can be a rational number because 3 as a fraction is 3/1. And then you can have -5 as a rational number because that's -5/1. So basically anything that can be written as a fraction. If you have a decimal, you could have 0.45 because that is 45/100. So as long as you can take a decimal and turn it into a fraction or write any number as a fraction, that is where we get and we call it a rational number. It doesn't have to be written as a fraction in order to be classified as rational, as long as it can be written as a fraction, okay? The next one we're going to talk about is the set of positive and negative whole numbers. So these are the set of integers. So integers is the set of positive and negative whole numbers. And the symbol that represents integers is the symbol Z, okay? And that is the set of, like we said, the set of all positive and negative whole numbers. So it's like your whole numbers on a number line. So you can have -5, +7. You could have 3.4 times 10 to the power of 2, because 3.4 times 10 to the power of 2, we know that that is equal to 340, and 340 is an integer, okay, because it's a positive whole number. Next, we have the set of natural numbers. So natural numbers are numbers how we naturally count, okay? And we naturally count starting off like with 0, 1, 2, 3, 4, okay? So that is the set of natural numbers, which is denoted by the symbol of N. And counting numbers, like we say, is 0, 1, 2, 3. So I like to tell students that it's the set of all positive integers. So let's look at 2 examples in classifying these. Example number 1 says, mark each cell to indicate which number sets the number belongs to. So all of these numbers do not have an I on them, so we can automatically classify them as real numbers. Okay? Then next we want to write down all of the numbers that can be written as fractions. So I know -2 written as a fraction is -2/1. So yes, it is rational. 3/7, of course, it is a fraction already, so it is rational. The square root of 13 is equivalent to 3.6055551275. As you can see here, there is no pattern. Remember, decimals cannot be written as fractions unless it is a clear pattern, which means that either the decimal truncates or cuts itself off, or either you see like 4-5-4-5-4-5, or 3-3-3-3-3-3-3-3, or 6-6-6-6-6-6-6-6-7, to where you can tell there is a pattern going on. So this has no clear pattern, so it is not rational. Okay, 3 pi is equal to, and you can find these values using your calculator, is equal to 9.424777961. As you can see here, the decimals have no clear pattern, so it is not rational. And then we already know 10,000 can be written as a fraction. It's 10,000 over 1. So next, we're going to write numbers that can be an integer, which means a number that is either a positive or negative whole number, meaning no decimals. So -2 is a positive or negative whole number. 3/7, the square root of 13, and 3 pi, they have decimals if you were to put it in the calculator or divide by hand or multiply by hand. And then you have 10,000, which is a positive whole number as well. So it is an integer. And then we talk about natural numbers, which are positive whole numbers. And the only one that fits the bill there is 10,000. Now, irrational is the opposite of rational. So remember, if rational means you are able to write it as a fraction, then that means that irrational means that you can't write a number as a fraction. So the square root of 13 and 3 pi are both irrational numbers. Okay, now let's move on to number 2. So we want to place the following numbers in the Venn diagram below. So what you need to understand is that all numbers are in the subset of being a real number. So any number, no matter if it falls in here, here, or here, they are all real numbers. I can say the same exact thing about my rational numbers. If any number can be written as a fraction, it will either be here, here, or here. Okay? And it goes inward as we go further into all the way to the natural numbers. You only want to put a number once. Okay? If it is in this box, it is a real number. All right? So if we look at the square root of 5, the square root of 5 is the same thing as saying 2.23667977. So we see no clear pattern of the decimals, so square root of 5 is just a real number. And we know that we don't have to have a spot for irrational, because we already know it's irrational because we don't have it inside of the Q circle. The next thing we have is -3/7. So -3/7 is a real number, but it is also a rational number. So instead of writing it in the R rectangle, we can write it inside of the Q circle, because the Q, or the rational circle, is already on the inside of the real rectangle. Okay, so we already know because it's inside of Q, it has to be inside of R, because Q is on the inside of R. All right, remember, you only represent the number once. All right, the next one that we have is pi, and we know that pi in its raw form, remember we're talking about the raw form, pi is going to be equal to, let me write this one in a different color. Pi is equal to 3.141592654. So it's no clear pattern. So I know that pi has to go inside of the real box only. All right. The next one we have is -5. -5 is a real number. It can be written as a fraction, and it is also a positive or negative whole number, so it's an integer. So I'm going to write -5 inside of the integer circle. And then we have 7. 7 is a real number. It can be written as a fraction, 7/1. It is a positive or negative whole number. It's a positive whole number. And we know that it is a natural number, so we can put 7 here. We also know that 2 to the power of 3 is equal to 8. And 8 is also a positive whole number, which means it is natural. So we can put 2 to the power of 3 inside of the natural section. All right, so that is the lesson on special number sets. So if you have any questions, reach out to me and I will help you. Have a great day.